Hello everyone, this is the very first lab for construction surveying. Lab 1 is horizontal distance measurement, and we're going to learn different methods how to measure horizontal distances. So you know that, let's say from A to B, there are three distances we can imagine. A to B, which is a slope, and then this is the horizontal distance and difference in the elevation, which is the vertical distance. Today we're gonna deal with horizontal distance. There are different methods which vary in terms of accuracy and precision. Today we're gonna learn estimating, pacing using real odometer and taping. The accuracy of these would be different. The estimate is the least accurate, and using tape is the most accurate one. Okay, when it comes to precision, the precision depends on your performance and also how skillful you are when you estimate. For estimating, so it depends on you, but for pacing it depends. Similarly, for pacing it depends on you as well, but for real it is limited to a tenth of a foot or an inch. In our labs we have both cases. Some of them are said to be accurate to an inch, some of them to a foot, and for tape, nearest hundredth of a foot would be the case. Okay, so the first three activities are individual. Estimating, you just guess the distance from A to B. For pacing, you simply walk, and using wheel odometer, you grab the wheel, put it on the ground, start walking. And for taping, you need to work with your team partners. You're going to learn more how to do this. Okay. Estimating, you know that it's accurate to the nearest foot, right? And we intuitively do this. We have, I believe, all of us have estimated some distances in our life, and when we estimate, we reasonably round it. Okay, when you want to measure, let's say, the length of a building, okay, you don't say it's like 70.25 feet, right? You usually round it properly. And for our lab, when it comes to estimate, you need to also round it to the nearest foot. And as always, you know that numbers in construction without units are meaningless in construction surveying. For pacing, in order to increase the reliability of our results, we take 5 steps and calculate the average of one step, the average length of one step. So we mark on the ground, start walking, take 1, 2, 3, 4, and 5 steps. You steady and normally walk, and you measure this distance using a tape, and you basically divide it by 5. It would be the average of one step. You start walking from A to B. You start walking, and then you count. You multiply it by the average, and then round it to the nearest foot. And for the lab, you have to show your calculation. These are the activities that you can also practice at home. Well, the technology is very simple. That it's similar to pacing as well. So for the wheel, we know the perimeter of the wheel, and we count how many full like circles have passed from A to B. Going from A to B, we can measure the distance, right? These technologies are used also in our vehicles and cars, and it's not that complicated. For taping, you measure twice, going forward and reverse, and you calculate the error, which is the difference between two measurements. And you also need to calculate and report the error ratio. This taping is the only method that we measure twice, because other methods are not that accurate, and just doing more than once doesn't make sense for them. Okay, what is the reason to walk one more time to increase the accuracy while you know that pacing is not that accurate? But for taping, it is the instrument itself is accurate to the nearest hundredth of a foot, and if you measure more than once, you can increase the reliability of your numbers and accuracy. And measuring twice gives you the ability to calculate the error ratio. In order to refresh your mind, the error can be calculated as forward distance minus reverse distance, basically the difference between two measurements that you have. And if you calculate the average of these two, which usually, basically will be reported as the measured distance, is you add two measurements together, divided by 2, and then would be the mean distance. For error ratio, it is error over the mean distance, so error comes from here, mean distance comes from here, and it is expressed as 1 over the nearest hundredth foot. One example, for example, 1 over 30/100. And for professional surveyors, it is expected to get 1 over 5,000 error ratio. Here is an example just to practice. Let's say in your lab, your classmates measured the forward distance of AB to be 477.04 feet, and the reverse distance to be 476.89 feet. Calculate the error ratio, mean distance, the error, mean distance, and error ratio. Error is just simply the difference between two. It could be positive or negative. That's in both cases would be possible. In my case, here I got 0.15. The mean distance always is positive. There is no negative distance. And you just simply add them together, divided by 2. In some cases, you might need to round properly. Let's do that. And then keep 2 decimal places, 476.97 feet. Then error ratio is 0.15 over 476.97. If I make the numerator to be 1, the denominator would be 3173. I need to round it to the nearest hundredth. I will get 1 over 3200. Okay. Let's see when you want to do the lab. Let's talk about the points on the ground using wheel and where to go. So we picked 3 points on the ground. One is up in the hill, and uphill, downhill, and then C is also in on the flat surface. So BC is roughly speaking horizontal line, but AB is curved or slope. Measuring BC is easy, right? Even in all 4 cases of estimating, pacing, wheel, and tape, it's easy because the horizontal distance is on the ground, right? But for AB, it's totally different. You cannot grab the wheel and just walk up in the air, because theoretically you need to measure this distance. The only instrument that gives you the ability to measure the horizontal distance, not the slope distance, is the tape. I will show you how you can do this, and you will learn how a tape can be used for measuring this horizontal distance. Okay, here's where we went with Mr. Josh Pitzer, the lab manager, and normally all our labs were conducted here. This is the CT building that usually the lab classes were conducted somewhere here, and this is the raw building where the department is located, and we had these points over here. Okay. As always, if you have any question, just let me know. I will demonstrate how these lab activities can be conducted. Thank you. Hello everyone, my name is Dr. Mustafa Namian. I am the instructor of Construction Surveying Lab. Today, with the help of Mr. Josh Pitzer, the lab manager, we are demonstrating the lab activities. We start with the very first lab, horizontal distance measurement. As you see, we all have masks. We are wearing masks, which means we are recording these videos during the pandemic 2020, and we had to switch the labs to be online. Obviously, these cannot replace the experience that you could have gained having your hands on the equipment, but obviously this is better than nothing. We try our best to give you the highest level of quality for education and demonstrate the details of labs that you can learn maximum out of these videos. Okay, so the first lab is horizontal distance measurement, measuring from A, which is a point uphill, to B, which is downhill. AB would be a curve or slope distance, and B to C would be roughly speaking flat surface. So we need to use different methods to measure from A to B, then B to C. It's important to know that when we say measuring from points, we don't mean flags. These flags are visual hints to find the points. We are measuring from the intersection of these pins into the grounds. Today is a sunny day and the weather is 86 degrees. As you know, we need to report the temperature and weather as professional surveyors because it impacts our results. So 86 degrees Fahrenheit, the temperature, and it's a sunny day. So we start with different methods of measuring A to B and then B to C. The first step is estimating. Let me grab this wheel. So let me ask Mr. Josh to guess the distances from A to B and then B to C. These are just these points are randomly selected, so we have no idea the accurate distances of these points. So what do you think, Mr. Josh, from A to B?
I'll say 10 feet from A to B.
10 feet A to B. How about B to C?
9 feet.
9 feet. A to B, 10 feet. B to C, 9 feet. Let's see how accurate it would be. But let me tell you, even though estimating is a fast way, it's not that accurate and reliable. And the accuracy, in fact, depends on your skills and experience. It is very fast, and in some cases it is beneficial and useful if you want to just have an idea of the distances. But if you want to build something, definitely this is not the method that you want to do. The second method is pacing. So the pacing is you just normally walk on a flat surface, and then you measure the distances of 5 steps using a tape. And using that tape, once you measured 5 steps, you calculate the average of those 5 steps. Okay, now what I'm going to do is do the pacing. For pacing, what you need to do is just mark on the ground, put 1 step right on the mark, and just start walking 5 steps normally. 1, 2, 3, 4, 5. Okay. Then what you need to do is use the tape and measure these. So here it is 9.5. steps. So you need to calculate the average of one step and then multiply that average and the number of steps that you took from A to B and also B to C. That would be your measure. And just normally walk from A to B and then B to C and count. So let me start. 1, 2, 3, 4, 5, 6, 7. Okay, 7. 1, 2, 3, 4, 5, 6. 7 and 6. 7 A to B and 6 B to C. The third method is using a wheel odometer. This is the technology that all of us use on a daily basis, and all of our cars and vehicles have and use this method to measure the distances. The first step that you need to do is to make sure it is reset to 0. This instrument that I have is accurate to the 10th of a foot. Okay, and then the center of the wheel has to be projected on the point. Once you place this wheel on the ground and the center is on the point, you reset one more time and then grab this wheel and you try to just walk. The main point that you need to do is try to make a direct and a straight travel from A to B. Do not divert, do not go off. So you just normally walk from A to B. Once the center is on point B, you record. So it is 11 feet and 11.8 feet. So Mr. Josh, I would say, made a good guess. It was good, given that this is a slope distance and we are asked to measure the horizontal distance. So we know that the horizontal distance would be shorter than the horizontal than the slope distance. So the horizontal distance is shorter than the slope distance, and the negative point about using wheel is that it actually measures the slope distance, not the horizontal distance. So I would reset this once again and then start walking from B to C. B to C, it is 11 feet. So 11 feet, this is exactly, it's an even number. 11 feet is B to C. So again, Mr. Josh made a very good guess. Good job. So those three methods very, very fast, but you know that those are not that reliable. The fourth method is using a tape. When it comes to using a tape, if it's a flat surface, it's not a big deal, so it's easy. But if it is a slope, then it needs more effort to come up with a more accurate number. So first, what I'm gonna do is measure from B to C. It's a flat surface. However, it's better to start from A to B. So Mr. Josh is holding the 0 end on point C. Other surveyor holds the 0 end next to point C. And what I'm doing is just pulling it tight, okay, and read that. So now what I'm reading is 11.08. So you see that it's pretty close to the wheel. And the thing is, the wheel was 11.1. The wheel was accurate to the nearest tenth of a foot, but the tape is the 100th of a foot. So we were not able to measure this accuracy using the wheel. But the wheel and tape are pretty close in this case. But when it comes to the slope distance, that's a totally different story. As you can see, zero end got a change, and it might be confusing for you. What you can do is to hold the tape from 1 foot and then cut off 1 foot, and when you read your measurement, make sure to subtract 1 foot. So the rear server holds the 0 end, the other end next to the point, and what I'm doing is I am holding the tape to make sure that I'm measuring from A to B. So the point is I'm trying to hold this horizontal. That's my goal, that's my aim. But I might not be able to do that. What I need to do to make sure that it is horizontal to get the hand level. This hand level is important not only has bubbles. And what you can do is put it on top of the tape and then look through these. In some cases it might be difficult to look through. It got a bubble on top as well, so what you can do is just look at that bubble from top and moving your hand up and down, you can make sure it is horizontal. So when the bubble is in the middle or in between the marks, then it is horizontal. But how can I make sure that I am projecting the point in the air to the ground? That's where I need the palm bob. So I use a palm bob, okay, and the palm bob gives me a vertical line that I can connect my point on the tape to the ground. So I make sure the tip of the palm bob is hitting my point, and so and then see where the string gets to the tape. So I need to pull the tape tight. It gets windy, so you might wait for a few seconds until it's done. Then you read your tape and make sure at the same time you need to make sure it is pulled tight, it is horizontal, and the palm bob is hitting the your point. Now I'm reading 12.58. 12.58. However, remember that I started from 1, not from 0. So I need to subtract 1. So it will be 11.58. 11.58. So once you do your measurement forward from A to B and B to C, you start from C to B and then B to A one more time. That's your reverse. To be able to do your ratio and calculate it. The difference from A to B and B to C is that A to B is on a slope area, and then you need to make sure you pull the tape tight and it's not saggy, so it would impact your results. We want a very straight and horizontal line. You need to pull it tight and then make sure you read it once it is perfectly horizontal. So you try your A. Let's say A to B is too long, then you grab another pin, break it down into 2 or more distances. You let's say that's point B prime, you measure from A to B prime, and then from B to B prime to B, you add them together. That will be your distance from A to B. That's very important to do if you're not able to measure from A to B directly just once. By one measurement you break it down. Once you measure it, then you calculate it, you add them together, you calculate it, and that would be your horizontal distance measure.